This 9.5 is trigonometric ratios. Hey, there's a handful of trigonometric ratios that you'll come across throughout the rest of your math careers. Hey, we are just going to talk about 3 of them today. Most of you are going to recognize these 3 words. Okay. The first one is the sine. Second one is the cosine. And the third one is the tangent. Okay. Have you guys at least heard those words before? Most of you probably have at least heard them before. You will recognize on your calculators there is a sine button. It looks like that. There's a cosine button. Looks like that. And there's a tangent button. And it looks like that. If you don't have a calculator, I do need you to go get one. You're going to need it. Now we had to correct a little confusion here. In the last class, is this sin? No. Is this cos? No. That's sine, right? That's cosine. Is this tan? No, that's what you do at the beach. This is tangent. Okay? Can we say these properly for me? I know in the past you may have always read them as sin, cos, tan because you didn't know what they were. Okay, but now that we do, let's refer to these as sine, cosine, and tangent for me, okay? Can we do that? That way we're all on the same page and we're using the proper terminology. Okay, so we have the sine, cosine, and tangent. Now, in your book, there is a green box with all of this in it. Does it say theorem, though? No. So it doesn't go on your theorem sheet, okay, but you are going to want this in a place where you can easily find it. And I'm going to flip this around so it looks exactly like what you have in your book. Okay, they have your angles labeled here. And your sides. Notice A, B, and C, just like with the Pythagorean theorem, right? Okay, that's just how you label a triangle, typically, as the sides A, B, and C. Your C is always where? Your hypotenuse. Okay, your A and B don't really matter. Now, I do want you to notice, though, my angle A is capital, right? Okay, your angles will always be capital letters. Your sides will always be lowercase letters. Notice capital A is opposite of lowercase a. Capital B opposite lowercase b. Capital C opposite lowercase c. So C is always either your hypotenuse or your right angle, correct? Okay, as long as we're talking about right triangles, that is. Alright, so let's start with our sine. Okay, we're just going to find the sine of A. Okay, we're going to slowly work our way through this and progress here. So I have the sine of A. Okay, your sine, and again, this is probably new to all of you, the sine of any angle is always the opposite divided by the hypotenuse. And that's referring to the sides. So to find the sine of A, it's going to be your opposite side, which is A, divided by your hypotenuse, which is C. So it's going to be A divided by C. If I asked you to find the sine of B, what would that be? B divided by C, correct? Okay. What's our next function? The cosine. So I have the cosine of A equals, now your cosine is adjacent divided by hypotenuse. Okay. So from angle A, what side is adjacent to angle A? B. Divided by the hypotenuse, which is C. Now, I did have a lot of questions last class period, and it made sense when you think about it. Isn't C also adjacent? Yes, but that's the hypotenuse, right? And throughout all this, doesn't it have its own spot? So is your hypotenuse ever going to be your adjacent side? No, your hypotenuse is just always your hypotenuse, right? Okay, just keep that in mind. Your hypotenuse is always just your hypotenuse. It'll never be the opposite. It'll never be the adjacent. So if the hypotenuse can never be the opposite, can we find the sine, cosine, tangent of this right angle? No, because wouldn't we need the opposite? Okay, so you'll never find sine, cosine, or tangent of your right angle. It's only going to be of your acute angles. Okay, so never your right angle, only your acute angles. And then our third function was tangent. So the tangent of A is equal to, tangent of A is equal to the opposite divided by the adjacent. So going from A, opposite of A is A divided by B. Good. What if I found the tangent of B? It'd be opposite, which is B, divided by adjacent, which is A. Okay, so is it going to change when you change what angle you're using? Your opposite over hypotenuse won't, but these letters will change, right? Okay. Now, that can be kind of hard to memorize, correct? Yeah. Okay, so I'm going to give you a little acronym here to hopefully help you remember this. Now, there's a lot of different acronyms you can find online. I think I'm using the right word. Like a saying for something, that's an acronym, right? Okay. The one that I've always used and that people tend to use most often, if you use this around any math teacher, whatever, they're going to know exactly what you're talking about. Okay? SOHCAHTOA. SOHCAHTOA. To me, it sounds kind of like a Native American word, so it's easy for me to remember. Okay? SOHCAHTOA. So, what this stands for is that the sine is the opposite divided by the hypotenuse. So what's this C stand for? The cosine, which is adjacent divided by hypotenuse. And then the T stands for tangent. And we know that the tangent is the opposite divided by the adjacent. SOHCAHTOA. SOHCAHTOA. Hey, again, there's a lot of different acronyms you can find online if you just Googled it. Some of them are not exactly what I would consider school appropriate, so we're not going to go into those a whole lot. Hey, but however you want to find to remember it is fine. If you just want to use SOHCAHTOA, hey, that's great. Hey, but that's something we're going to need to know. Okay. Everybody got it? All right, so if I have a triangle, I don't know what the angle measures are, and at this point it doesn't really matter. Okay, but let's just go ahead and say it's a 5, 12, 13 right triangle. And that's angle A, B, and C. How am I going to find the sine of A? Yeah. It's opposite over the hypotenuse. What is the opposite side? And the hypotenuse is 13. Now, some of you are going to like this, some of you are not. Your trig functions need to be in decimals. Okay, they have to be. Okay, because we're going to get into angle measures and stuff like that with these. So, your trig functions and your directions in your book are going to tell you this, need to be rounded to 4 decimal places. Okay, so this is going to be 0.9230. Three one. So yeah, that was the thing that was coming next. Make sure we round these correctly. I know we haven't rounded a lot in this class because we work with exact answers usually. Hey, but we need to make sure we round our answers correctly. If it's 5 or bigger, if that fifth number is 5 or bigger, you need to round that next number up, right? Okay. So the cosine of A would be what? Cosine is adjacent over hypotenuse, so it's 5 over 13, which equals 0.3846. Is anybody not getting these answers? Because your calculator might not be in the right mode. You're not? I just got to change your calculator mode. You should be. You just need to take your numbers and divide them.
Oh, okay. I'm saying that one we have to.
Okay, so that's the other thing we ran into. Are we pushing the sine, cosine, tangent buttons yet? Or right now we're just dividing two numbers, right? Because to find the sine of that angle, if they tell me to find the sine of A, you just need to take the opposite and divide it by the hypotenuse. Okay, don't use the sine button yet. We'll get to that in a little bit. Yeah.
So what are those numbers?
It's the sine, cosine, and tangent. We're gonna use them to find side length, and we're gonna use them to find angle measures later. Okay, so we're slowly working into, you know how we talked up here, how we're gonna find these side lengths? We're getting there, but first we have to know how to find the sine, cosine, tangent. Okay, so we're slowly getting there. Okay, so now let's do the tangent real quick. The tangent of A, tangent stands for opposite over adjacent, so it's 12 over 5. 2.4. Now, obviously, if there's no rounding to do, you can't put 4 decimal places, right? If you wanted to put 3 more zeros, that'd be fine. I'm not going to count that wrong. Okay. Could I find the sine, cosine, tangent of C? No, you'll never do the right angle. Could I find it of B? Yes. Okay, and as you slowly work through, you're going to find a relationship here. Your sine and cosine of these opposite angles are actually going to flip, right? Because the sine of B would be 5 over 13. So that would actually be the cosine of A, right? So the sine of A is actually the cosine of B. The cosine of A is actually the sine of B. Okay, you'll figure that as you go. Just think about it as individual angles if you like it first. Okay, so here you just divide, right? We didn't push the sine, cosine, or tangent button at all, correct? Okay, so let's get into a problem where you might have to. I think this is example 5, maybe 6. Example 6 on your book, actually. Okay, they give you an angle of elevation is what they give you. I believe it was 59 degrees. Okay, they told you this was 45 feet. I believe. Yep. And they want to know what is the height, and in this case it's actually a tree. They want to know what is the height of this tree. Okay. This would be really easy if this happened to be 60 degrees, right? But it's not. Okay, so now we have, since it's not a 30-60 or a 45-45, since we only know one side, okay, that's how you're going to know that you have to use your trig functions. Okay. Now, just always use the angle they give you. It'll be easier that way. So they give you this 59 degrees. From that angle, what sides do you know? Well, H is opposite, adjacent, or hypotenuse. H is opposite. 45 is adjacent. So which function do we know that uses the opposite and the adjacent? My tangent. Okay, so that's how you're going to have to look at that. Okay, here's my angle. Here's the side lengths I want to work with. Where are they at from my angle? In this case, they happen to be the opposite and the adjacent. So I'm going to use the tangent of that angle, 59, equals what? H, the opposite, over the adjacent. Okay, so we just set up our equation. The difference between this and what we just had is up here, we didn't know the angle measure, did we? But we knew both of the sides. Down here, we know the angle measure. We're trying to find the side. Okay? So, how do I go about solving an equation? Just an equation. It looks a little different than what we're used to. But how do I go about solving an equation that looks like that, Jacob? Right, because right now I'm dividing by 45, right? So like Jacob said, I need to multiply by 45 on both sides, because what I do to one side, I do to the other. Okay, so now I have 45 times the tangent of 59 equals h. Do I have my variable by itself? Okay, does everybody know where your tangent button is on your calculator? Should you be able to take 45 times the tangent of 59? Yeah. And since I'm finding a side length, you don't need 4 decimal places. But what do I get for my side length? I'm going to do 2 decimal places here. What's my label? Feet. Did anybody not get that? Because if not, there's a couple things. We could be punching in the wrong numbers, or your calculator could be in the wrong mode. So I need to make sure we have that if you didn't get that. Did everybody get that? All right. Okay. You're going to have to set up these equations. Okay. It's going to be pretty challenging if you don't. Okay. So let's do another one here. We're going to do one like example 7. Okay. It's not going to be the same though. I'm just going to pull one randomly. Okay. Taylor Hart, what do you want this side length to be? 42. Okay, that's x. Vincent, what do you want this angle to be? 35. Okay. So again, not a 30-60 or 45-45, correct? I only know one side length. I want to find what that hypotenuse is. Okay. So first thing you need to do, go to your angle. Okay, so here it is. What is the relationship of the sides that I know from 35? I know the opposite and the hypotenuse. Remember, this is opposite the right angle. So that's never going to be our adjacent side. So I know the opposite and I know the hypotenuse, correct? Ryan, which function uses the opposite and the hypotenuse? The what? Sine. Thank you. Okay, so the sine of, what's my angle? 35 equals 42 over x. So it looks very similar to what we had a second ago, but what's the difference? The x is on the bottom. Now what? It's a good thought. Also a good thought. Now up here, I multiply by the denominator, right? You still have to do that. Okay, because if I multiply by x over 1, don't these x's cancel? Okay, obviously I got to do it to the other side. Okay, so our main goal here is get rid of the fraction. Okay, so let's get rid of the fraction. So now I have x times the sine of 35 equals 42. Okay, so my fraction's gone. That's good. Is there still something with x, though? Yeah, how do I get rid of that, Jacob? Good. I divide by the sine of 35. And I know that's a process you guys have never done before. Okay, but it makes sense because I got x by itself and I'm multiplying right now, right? So what happens to these two? They cancel. So you have x equals 42 divided by the sine of 35. Can you plug that straight into your calculator? Yeah. So you get 42 divided by sine of 35. X equals 73.22. And I didn't put a label, so you can just leave it just like that. Put units maybe if you want to. Okay. I only need 4 decimal places if it actually tells you find the sine, find the cosine, find the tangent. If you're finding side lengths, you don't need to. It'll probably tell you what to round to. Okay? So just read the directions carefully. It'll probably tell you what to round to. Okay, I have one more example for you. We ready? Last one. Okay, they have a driveway here. This is an extra example out of your book. They have a driveway. It goes, the angle of elevation is 3.5 degrees. Okay, so that's the angle that the driveway is going up at. The driveway over the whole length rises 12 feet. Okay, so pretty tall driveway, right? But we got to figure out, it's obviously not very steep with 3.5 degrees. Okay, so we got to figure out how long is this driveway. So I want to figure out this side, correct? Okay, so I want to figure out how long it is. Okay, so from my angle, Lainey, what sides do I know? That's the opposite, and this is the adjacent. Good. So what function uses the opposite and the adjacent? Tangent does. Okay, so I know I'm going to use the tangent of 3.5 equals 12 over x. Now I'm pretty much in the same boat I was the last problem, right? Okay, so you multiply by x, right? Everybody agree with that? Okay. So I have x tangent of 3.5 equals 12, and then I divide by what? Divide by tangent of 3.5. And what is the length of my driveway? $196.20. Pretty long driveway, right? Maybe it's out in the country. Maybe it's... That's probably your best bet, actually. 196 feet. Pretty long. Now, that brings me to another rounding example. The answer was actually 196.198, right? Is that right? Okay. Obviously, if you're trying to round to 2 decimal places, that 8... Okay, so I have my 8 over here. That 8 changed the 9 to a 10, right? So you got to carry your 1. So you have 196.2. If you want to put a 0 there, you can. Okay, so just make sure we round correctly. Okay. On today's homework, you're actually only going to have one problem like those last 3 examples we did. The rest of your problems are going to be like this. Okay? So on most of your problems, are you even going to use the sine, cosine, tangent buttons? No. Okay? But there is going to be one where you do. For sure one. Maybe more, I'm not for sure. But for sure one. Otherwise, most of them are going to be like this. Okay? Next class period, we will have an add-on. Class period after that, we're going to take our quiz. Okay, we do have a 9.1 through 9.5 quiz that we will take in 2 class periods. So this is what I need you guys to do for me for tomorrow.